Hello everyone. In the previous classes, we have discussed regarding what do you mean by substation, what are the different equipments of substation we have, classification of substation, site selection for substation, and bus bar arrangement schemes. Okay, these topics we have already discussed. Okay, now the moving on to the next topic, that is grounding. Here we will be discussing regarding what do you mean by grounding, what do you mean by grounded system and ungrounded system, and what are the different grounded systems we have, that is solid grounding, resistance grounding, resonant grounding, neutral grounding. These topics we will be discussing now. Coming to the introduction, you all know what you mean by grounding. Grounding is a method by which we can avoid ourselves from electrical hazards, and it is a best common practice to connect the electric power system or electric supply system to the ground at suitable points, because when we connect, when we do the grounding, okay, it provides a conductive path for the fault current to the earth. It provides a conductive path for the fault current to the earth by using a low resistance wires. That's how we can protect or avoid ourselves from electric shock or electric hazards with the help of grounding. Grounding is also a protective measure. It is also a protective measure against lightning. Okay, this is the basic simple introduction regarding what you mean by grounding. Now we have basically two types of systems we have in the power system, that is grounded system and ungrounded system. First one is grounded system and ungrounded system. Let us look into what you mean by grounded system. Grounded system is one in which at least one conductor or point is intentionally grounded, which means grounded system is the one which will be equipped with a grounded conductor, but one grounding point will be there, in the grounded system. Okay, this conductor or grounded conductor, okay, can be used as a current carrying conductor to accommodate all neutral related loads. And this grounded conductor can be used to clear the ground faults in the system. If there is any ground faults, in order to clear the ground faults, we can make use of this grounded conductor. Okay, basically grounded system means a system which consisting of at least one grounded conductor, or will be equipped with one grounded conductor. That is grounded system. Okay, ungrounded system. Okay, ungrounded system is the one which operates without a grounded conductor. There will be no any ground point. Okay, a fault creates a arc between overhead line and the ground here. Okay, suppose if you look at here, this is a three-phase system. It is a three-phase system, A, B, C, three-phase system. Okay, which is not grounded. Okay, the neutral point is not grounded. It is a three-phase ungrounded system. Okay, here what happens means a fault creates an arc between the phase and the ground. This arcing ground is a very common in ungrounded systems. Okay, when there is no fault, the distributed capacitance, these capacitances of the line gets charged to the respective phase voltages. Okay, whenever there is no fault, this capacitance will get charged Okay, this capacitance will get charged to the respective phase voltages. Okay, the charge capacitance, now let us see with respect to particular phase, the charged capacitance of phase C, okay, phase C get discharged, get discharged through the fault F, through the fault F between the phase C and the ground, phase C and the ground. Okay, the charge, okay, the capacitor with respect to phase C will get discharged through the fault F between the phase C and ground. Okay, these capacitance again gets charged in the opposite direction and again discharges. This repeatedly charging and discharging is referred to as arcing ground, is referred to as arcing ground. Okay, basically the phenomena arcing ground occurs in the ungrounded three phase systems because of flow of capacitive current. Okay, because of flow of capacitance current. Okay, this arcing ground produces severe voltage oscillations. Okay, severe voltage oscillations which will be 3 to 4 times of normal voltage. Okay, which will be 3 to 4 times of normal voltage. Okay, this problem, okay, whatever the arcing ground we have, this problem can be solved by earthing the neutral, by earthing the neutral point. Is that clear? This is the ungrounded system.